Aloha! In this video, I would like to discuss the role of analogical reasoning in artificial intelligence. Today, artificial intelligence is often equated with large language models, which are built on neural networks. These models, from ChatGPT to DeepMind's AlphaFold, are products of the connectionist approach to AI. However, AI has historically been shaped by five major schools of thought: symbolists, connectionists, Bayesians, evolutionists, and analogists. While connectionism dominates today, the analogist approach, rooted in the power of analogy, remains an intriguing and valuable perspective in AI development. Artificial intelligence is not just about computing. Rather, psychology plays a significant role in its development. The psychological foundations of analogical reasoning trace back to the 19th century. In 1890, William James argued that humans make sense of the world by detecting sameness between different events and objects. In his view, perception and cognition are not just about reacting to stimuli, but about recognizing patterns and relationships across different situations. He asserted that the mind operates by selecting, emphasizing, and combining past experiences to make sense of new ones. For example, a child learning how to use a computer for the first time might compare it to something they are familiar with, like a book or a television, helping them form an initial model of how a computer works. Modern psychological research supports this idea, suggesting that people build mental models of the world and use them to make inferences about new situations. A key example is structure mapping theory, developed by cognitive psychologist Deirdre Gentner in 1983. This theory highlights the difference between literal similarity and structural analogy, emphasizing that meaningful analogies map relationships rather than superficial attributes. For instance, the solar system and an atom share a structural commonality. Just as planets orbit the sun, electrons orbit the nucleus. However, the fact that the size of an atom and that of celestial objects is incomparable doesn't matter. Cognitive scientist Douglas Hofstadter and psychologist Immanuel Sander even argued that all intelligent thought, whether simple common sense or groundbreaking scientific discovery, boils down to analogy. Words and concepts are shaped by analogy. For example, the idea of a bottleneck in traffic comes from seeing a structural similarity between a road congestion point and the narrow neck of a physical bottle. This insight provides a strong foundation for analogist AI, as it seeks to replicate human-like reasoning by drawing connections between known and unknown situations. But how does this apply to AI today? While analogy-based AI has been overshadowed by deep learning, it still plays an important role in case-based reasoning, data analytics, recommendation systems, and meta-learning. The first example is case-based reasoning, CBR. Some AI systems solve problems by retrieving similar past cases, a method widely used in medical diagnosis, legal AI, and customer service chatbots. The second example includes nearest neighbor learning and support vector machines. These methods work by identifying similarities between different cases, mimicking human reasoning when we recall past experiences to solve new problems. The next example entails recommendation systems. Platforms like Netflix and Amazon predict what a user will enjoy based on purchases or preferences of similar users, applying analogy at scale. The last example is meta-learning and few-shot learning. Instead of programming rigid rules, modern AI translation models learn from just a few examples, making analogical inferences to generalize new tasks. This learning-to-learn approach is becoming increasingly valuable as AI moves toward more flexible and adaptable intelligence. Although neural networks and statistical methods currently dominate AI, analogical reasoning continues to influence AI research, especially in areas requiring explainability, common sense reasoning, and problem solving with limited data. Moving forward, the integration of analogical reasoning with deep learning and symbolic AI may lead to more human-like, interpretable AI systems, capable of learning and reasoning beyond just pattern recognition. Thank you for watching. Mahalo.